All right, good morning, everyone. Thank you for your patience. We're ready to go now. Welcome to this webinar on second use batteries and what's going on in the south of Norway. This event is organised by the companies listed here and supported by the Competence Fund in the south of Norway. So our focus is on Norway, what's going on here, and predominantly in the south. Kind of just a background that you probably already know, there's a large amount of electric vehicles in Norway. These Norway's been progressive with the way that it has incentivised the purchase of these vehicles, and has a large fleet of over 400,000 if this is both pure EVs and plug-in hybrids. When we do the analysis of what we then expect to come back from pure end of life batteries, not other reasons for the batteries maybe returned from the fleet, we see there will be quite significant amounts of batteries will return within the next few years. And then there's what should we do with these batteries? What opportunities are there? There's either there's a kind of when the batteries return, there's the possibility to either reuse them, which we'll speak about today, or the recycling. Within the recycling side, there's a big initiative with a cooperation between Hydro and Northvolt, and it's run by Battery Retur, who will speak today, to recycle Norwegian batteries and then reuse them in new batteries produced in Northvolt in Sweden. Just as another quick note for news today was that Hydro, Equinor and Panasonic agreed a memorandum of understanding to look at cell production in Norway. So this would be the third initiative for cell production in Norway, in addition to Freyr and Morrow batteries. So yeah. So today our focus is on this energy storage. So with that, I'll take you over to Bernard, who will take us through what the University of Agder is doing and the program for today. So I hope you have a good day, and we'll look forward to the discussion later on as well. Okay, over to you, Bernard.
Thanks a lot, Stephen. Good morning. I will quickly, as Stephen already mentioned, introduce you to today's program, as well as to Universities of Agder's battery activities. First, quick start with the program. So we have quite a lot of industrial talks, mainly focus on the Agder battery region. We will start, as I already mentioned, with the presentation of the University of Agder, followed by several initiatives building second-use storages already, and also followed by companies who implement or would like to implement second use as an alternative to first use batteries. And after the last break, we will have two keynote talks, one about automated disassembly. So how do we get batteries from first use to second use at all? And one keynote talk about the requirements for second use. At the end, we will have a panel discussion where we would like to discuss upcoming questions and discuss the future of batteries. Just some general rules and remarks. I would like to mention that this workshop is recorded, as well as if you would like to ask questions, please use the question and answer tool on the bottom of the Zoom meeting. So you can just type in the questions and we will collect them for the panel discussion. If there's time after the talks, we will do it immediately. And also the presentations, just as a note, will be shared after the meeting among the participants. So now second use, the topic of which is very, very hot actually in the region of Agder, and we hope that it will get hot in other regions around the globe as well. I mean, there are already, but Agder is a very, very dedicated area in Norway at least. Just the initial figure, I always like to show that why Agder is, or why Norway is actually such a hot area for second use batteries. If we see the share of electric vehicles in Norway, we exceeded already 50% market share in 2018, meaning that every second car which is sold is actually an electric vehicle, meaning that there will be soon also a battery available, which can be used for second use applications. If we map that in this typical battery value chain, as you all know it, we have like this classical value chain from raw material production until recycling. And what we are trying to do is like, we would like to extend this classical value chain by this alternative route that we do characterization by automated disassembly and develop new second use storages, find appropriate applications, and feed them finally back to recycling to keep the raw materials in the loop. And in this topic, we will talk quite a lot about synergies, and that's also why we actually initiated this workshop, because we identified there are a lot of stakeholders among this classical and alternative value chain. So first of all, there are all the businesses. There are also a lot of authorities involved, like with new regulations when it comes to Green Deal, Green Shift, and also researchers and students. And what we figured out is that already some synergies are done between the industries, the same with authorities, so they talk to each other, the same with researchers. And what we would like to engage now, and especially with this workshop, is that we will also find synergy among all these stakeholders. Yes, now coming just to a quick overview what the University of Agder is currently doing in that field. We actually base all our research in terms of batteries on spent electric vehicle batteries. We cooperate with quite a lot of partners, for example, Batterieretur, Alternative Energy. By the way, they will have later on a talk as well. And based on that, we have three pillars where we do our research or where we focus. First, we have automated disassembly, where we take electric vehicle battery packs apart, but more to that in detail later on in one of the keynote talks. The second pillar, what we are doing, that's my main focus, that's second use of batteries. So we write controllers, we develop new storages based on different kinds of batteries, and we do field tests. And the third pillar is we are also quite heavily linked with the business school at the University of Agder. So we develop also business models for second use and automated disassembly. And these business models also have a very strong focus on environmental aspects. So that's basically what we all do under the rooftop of the University of Agder. And now, as the keyword for today, how we can collaborate. And this we will take further to the panel discussion in the end. I want for now just say thank you, and I wish you a very nice and informative morning. Now I would like to invite the first speaker, Radu from Repack. He has actually a master in computer science and an executive MBA, and he is also this new COO of the Repack company. Thanks for coming and participation.
Hi, thank you. I took control of the screen. I couldn't find the unmute button. Can everybody hear me all right? So thank you very much for the kind introduction. Good morning, everyone. It's great to be here. As Bernhard said, my name is Radu Achihe, and I'm the CEO and co-founder of Repack. We are an early stage startup with a mission of enabling maximum value generation for second life EV batteries. And we plan to repurpose them in a streamlined, safe, and cost-effective way. My talk today will be on a subject that most of you will be very familiar with, which is the reused battery industry, and which is an industry that we're very confident will be successful despite significant challenges. And we salute the efforts of everybody involved in organizing this workshop. I'm thankful for the opportunity to make the presentation. So I will quickly introduce the team, which is made of Jürgen, who's also on the call. He's a BCG consultant. He's experienced in renewable energies, and his master thesis was actually in battery system optimization, while I have 15 years experience in operational topics in the energy industry.
You're muted now, Radu.
I think we may have lost his, there may be some problem. He looks a little frozen. I don't know if Jürgen, you can step in during the call until we get him back.
Yes, I can step in. So I think we lost Rado on his operational experience from oil and gas. So he has 15 years of experience there and working both in Vishere startup and Schlumberger. And we are now also looking for our CTO to join the team. So if anybody on the call or knows anybody who would be a potential CTO candidate for what we're about to present, please feel free to reach out. So maybe you, Bernard, can help me with changing slides. Super. So on to the problem. So as many of you are probably already aware of, the volumes of scrapped EV batteries are about to scale up quickly in the years ahead. So McKinsey last year published a report stating that the volumes is estimated to grow from 1 to over 200 gigawatt hours in 2030. And this is not even including volumes from buses, commercial vehicles, and marine applications. So if you press another click, yes, thank you. Then this size of the size of the bubble will likely multiply by 2 to 3 times. So it's quite substantial, the problem that we're facing. And Norway is especially interesting. So if you go to the next slide, we will see that we have actually 10 times the concentration of the leading US state of California, where they have 1%, we have had 10%, and assuming on Oslo is actually a staggering 20% EV penetration. Next slide, we will see that Norway, this is the volumes that you also showed earlier, Bernard, will grow by 40% yearly now, up to 2.2 gigawatt hours in 2030. So quite substantial. So next slide, we'll see today the best way we can handle these highly valuable assets, although we know that 1 out of 3 of them is highly functional with 70 to 80% remaining capacity, is to shred them. And even some of them are only trashed and sometimes even burnt. So next slide, the reason why we're all here, I guess, is that we know that these can bring substantial value in second life applications, and real estate construction and grid applications are all domains and industries where we see that industry participants highlight that they believe batteries will become a valuable integrated part of their portfolios in the future. Next slide. Super, thank you. And on another very important part of this is how repurposed battery systems can also bring a substantial reduction in carbon footprint compared to new battery systems. So analysis that we did based on a study from 2017 is that a repurposed battery system in Norway can have up to 95% lower CO2 footprint compared to a new battery system if applied in Norway. And if you click again, this is also then supporting 6 out of the 17 UN sustainability goals. So it's both a financial opportunity if we're able to get the cost down and a sustainable opportunity. So next slide, please. So today, we already know this, we can go quickly through there's a highly linear value chain that has been dominating the industry for some time, where we just discard the batteries at end of life cycle. So now there's being built, if you click again, a circular value chain with recycling, and Hydrovolt is one of the examples of that. And we then saw an opportunity to then piggyback and build on this value chain, if we click again, to then add the repurposing onto this value chain, testing and sorting, reassembly and operation, thus maximizing the value of these assets before being wasted. So next slide. So today, this is not something new. This has been done by anyone, and Alternative Energy, which will speak after us, know all about this. But today, the issues that we see in the early challenges are especially fourfold. So if you click once more, Bernard, please. Yeah. There's a lot of manual operations that are required by one of the sites, and there are also then a lack of scale to the industry, which can also lead to a limited operational guarantee as the systems are still new in operation. So these are challenges that we need to overcome in order to bring these repurposed systems into the money for more participants. And that's what we in Repack intend to do. So if you go to the next slide, we see that the costs of today's system are priced significantly above what is, at least due to our calculations, above the commercial real estate break even. And that also goes for repurposed systems. So if you click again, we'll see that we plan to use automation, standardization, and low-cost production in order to take that into the money for commercial real estate, and thus bringing a 70% reduction to what we see in the industry, at least today. And we also believe that we are able to sustain this cost advantage on the next slide in the years to come compared to the new systems. Although we know that they will go down on the 7% yearly rate, we still believe that we are able to beat that cost quite significantly in the years to come. And if we click again, the upcoming battery directive, as I know most of you are aware of, will most likely also support and require this to repurpose systems to actually be reused, thus demanding this in the market. So next slide. Thank you. So how we plan to go about this is to partner up with existing players on both sides of the value chain. And on the left-hand side, we will then plan to partner up with disassemblers or battery recyclers workshops, where we can then get these disassembled and tested modules. We then reassemble them into ready-made battery systems and then hand them over to integrators. If you please press again, super, and which then install and integrate this into the customer locations, this being companies like Wonco, GK, Bravida, so etc. And if you click again, then at the real end of life, hand these over to the material recyclers so that we can recuperate the materials once they're actually end of life. Super. So yes, so how we plan to realize the repack concept is through a 3-step approach towards full-scale production. So we currently have a 2-year window of opportunity in Norway to catch this opportunity, and we plan to grab that by this approach. So first, we plan to have 2 phases of where we launch operational pilots in the market, and then raise more funds in between each phase in order to fund the growth towards the next phase and ultimately full-scale production in 2023. Super, so last slide. So we see there's 4 key reasons why we believe that the repurposing market will be very attractive, and especially from the standing point of us. So Norway now is the right place and time, and we have a window of opportunity to act. Secondly, it's that it's a large and fast growing market, and according to our calculations, this will reach more than 3 billion euros in 2030. Thirdly, regulatory support is expected to come with the new battery directive, which will likely then require reuse and repurposing. And lastly, that the carbon footprint will be significantly reduced of battery systems based on repurposed battery cells and modules. Super, that was everything from us, thank you. And as Rado highlighted earlier on, if you or someone you know could be our next CTO, please feel free to reach out during the call, after the call, or when you get these slides after. Thank you.
Super, thanks a lot, Jürgen, for your very interesting talk. Due to some timing issues, I think we just rush to the next talk from Alternative Energie, and I would really like to welcome Geir Landmo. He is actually the technical manager at Alternative Energie, and he is based on education and electrical engineer, and has also a lot of industry experience from before. Welcome, and enjoy the presentation of Geir.
Thank you very much. Good morning, everyone. Let's see. Okay.
Now you should have.
Yes. Okay. Thank you. Yes. Yes. My name is Geir Landmo, and I work for Alternative Energie. And could you please? Yeah. Okay. Yes. So. Alternative Energie was established in year 2000 by Svein Teisdal, who is also sitting next to me here. Hello. Yeah. We are 3 employees here, and last year the turnover for our business was just about 20 million NOK. Our 2 main business areas, I would say, is to make these complete off-grid power system. And the second one are the wheel loaders, which we have been selling diesel for quite a lot of years, but now is turning into electric wheel loaders. Now we are going to talk about the off-grid power systems. So these are the picture on the top here. You see the batteries we are producing here. And this together with solar panels, inverters, and so on, we make complete power systems, and mainly for cabins, holiday homes, which are not connected to the official power grid. Just for the wheel loaders, we have, as I said, been selling these for quite some years with diesel, but since we are in very good contact with the plant in China, we have been working together with them, and then we have been able to, that they have been making electric wheel loaders. So last year we got the one on the left side, which is a 400 kilo wheel loader. And now, just before Christmas, we will get the next one, which is 1,000 kilo. So it's a good development here for electric. Just to give a view of the grid power systems we are making. So we have the lithium battery, which is the main component in the system, which we get batteries mainly from Battery Retour, and we dismount into separate cells and have made our own design there for making a complete battery for either 24 volt DC or 48 volt DC. And we have a lot of combinations here which we can do to get enough, to get the power, the energy. So normally one of these battery packages are around 7.5 kilowatt hours. We have our own BMS system, which is really important for safety of operation of the lithium cells. We have a very long experience with this BMS system from, I would say the beginning of 2010, from when we worked with electric cars. So this is a very secure and well-known BMS system. So making sure the cells are not going too low in voltage or too high in voltage, and also doing the balancing on the top of the cells. So the system else is also then consisting of solar panels, regulators, meters, and inverters to create the 230 volt AC in the cabins. When we started in alternative energy in the beginning, it was more for cabins, it was more 12 volt DC systems, but now the need are becoming more and more 230 volt AC. And this is what we would, what we like, how we would, how we look on our business. We have the circular economy. Of course, we have been talking about this a little bit earlier now. But the best thing for the when a battery in the car is broken is to repair it. If that cannot be done, the second best is to reuse it in a new product and keep it. I think it's important that we are keeping it up here in this at this high level, with not to bring it back too far in the cycle. So also have the waste pyramid here, and where we are working in the reuse level, in the second level there, and it's I think it's important that they can keep it in a high level there. Our challenges for the off-grid systems at the moment, it's the access to the lithium batteries for us are we are suffering from we cannot get enough lithium cells, and there are several reasons for that. Some of them are that some car producers do not allow cells to be reused, but only recycled. And then back to the slide earlier, it's a I feel a little bit sorry about that, to bring it very good products too long back into the cycle. So another thing is that the cells from car crushers and so on, for example, are sold in the open private market, and this, of course, is also causing less availability for the professional use like we are doing. This will, of course, be better looks to be better in the years to come, but at the moment it's a lack of cells for us. And another challenge is that the batteries and the car and battery producers are not thinking about reuse when they are designing the cells, the battery packages for the cars. That's you can see more batteries are being a part of the chassis of the car. It's more glued together. If it's screw terminals on the batteries, it's easier to use in this second use. I don't know if you want to add something there.
Oh, I think that's good, but another challenge can be when we start what do you call it, recycling?
Yeah.
Recycling batteries, and start a recycling factory. You need a lot of battery cells, and it could be a problem for us who need also have too little cells, maybe. And I can also say that today the cost of the products we made are 250 to 300 euro per kilowatt hours. So the price is going lower and lower. So it's a good product.
So yes, and we are mainly on these off-grid systems. That's where we have been working so far. We see a lot of other areas which are opportunities, but at the moment we have been serving the off-grid. Yeah. Just also making a small comment here on the wheel loaders, which we also would like to change and to electric, and this is also a challenge for us. And new drivers there could, for example, also be VAT reduction, since the price is this
Yes.
session. Yeah.
Great, thanks a lot for your talk, Svein and Geir. Now we are actually reaching the break, but I just figured out that we are a bit beyond our schedule, so I just recommend that we move on and take maybe a bit longer break, the second one. I just have to switch the presentation slides now, and in the meantime I can introduce. Welcome, Charlie. Maybe you can request control. Yes, and
thank you,
thanks for
Bernard.
your presentation beforehand.
Thank you for the kind introduction. Yes, so I worked at TUI previously, and now I'm working in Greenstat, especially Greenstat Energy, as a project manager for solar energy, which has a very tight connection to energy systems and thus batteries. I'll present shortly Greenstat, and that's the picture that we use to describe a bit how we see the world in the future. It will be all powered by renewable energies, and that's what we are working on with the wind on land, solar energy on buildings, solar parks, green stations. So it's a benzene a gas station, but for electric vehicles. And then we would like to electrify all kinds of transport, sea transport, air transport, and also seafood production in Norway. So that's a bit what we are working on in Greenstat. Greenstat is a company which is financed by Norwegian persons. There are more than 800 actionnaires, owners, and many daughter companies. The core of our business is with the hydrogen, actually, as you can see on the left, Greenstat Hydrogen, but there is also Greenstat Energy, Greensight, which is a consultant company, Green Station, which is, we are working on the future of the new electric vehicle charging stations, and then some other companies that I don't really have time to describe fully, but today I wanted to speak especially about Greenstat Energy, which is the company where I'm working in. And so a bit of background for Greenstat Energy is that in 2019, Statnett came up with a report that said that Norway needs 50 new terawatt-hour to electrify its society. And that means electrifying transport, industry, and much more. And if we add the electrification of the oil shelf, then we add 10 new terawatt-hour. At the moment, I think that Norway is consuming 140 terawatt-hours. So 50 new terawatt-hours is quite a lot more. And so where can these 50 new terawatt-hours come from? Well, they can come from hydropower, which is what Norway produces the most. 98% of its consumption is actually covered by hydropower, but hydropower has a very limited now new addition capacity. There has been given approvals for 3 new terawatts. The upgrading will give 6 new, can give up to 6 new terawatts if it's profitable. And then there are new additions that can give up 14 new terawatt hours. But these 14 will mean destruction of nature, basically, because you'll have to go in enriched nature to get these ones. So we don't think there is a lot more than can come from hydro. Between 10 and 15 new terawatt hours will come from that. Then land wind has already 7 or 8, but due to the big conflicts, we don't expect it to grow much more than 15. solar has actually been given between 7 and 10 new terawatt hours. I don't know. For the moment, there is almost nothing in Norway. We are very far from 1 terawatt hour. So actually, it's a market very promising and just beginning in Norway. Then you have energy and offshore wind that can give between 10 and 20. But basically, solar can play a big role in that. But it's also to say that new source of energy are coming into the Norwegian mix. Some of the big things we are working on, it's mainly hydrogen. Hydrogen for heavy transports, as with the hydrogen trucks, but we are also working with the Vestfjorden Samband, so the ferry between Bodø and Lofoten that will go on hydrogen, and we already we want to produce the hydrogen for this ferry. But we are a neutral company, and so if we see that batteries will be better, then we'll use batteries. So we don't have any bias in the company, but we see that hydrogen will mainly be used for long maritime transport and with long distances. For the solar parts, so we install on houses and on industries, and we have also more creative projects going on, like land-based fish farm or some stations with integrated electric vehicle charging. Now I'm quite good with the time. So it is especially with houses and industries that we are considering installing battery packs. For the moment, we see that it's not profitable on grid connected systems because prices for the electricity in Norway is rather low and doesn't fluctuate so much during the day. While in other like European countries, you will have large fluctuations during the day that could make you want to store the energy and you could sell it when it's actually very profitable. So a battery system is much better in other countries. Norway doesn't have that for the moment, but Norway wanted to actually make companies and private persons pay more for the power peaks they were having, and that was before I talk a bit more about NVE, but there are already big projects in Europe. For example, this arena, I think it's in the Netherlands, where they will use 148 used Nissan Leaf batteries in this stadium. So it's actually a very cool project, but more in the Nordics. Then you have this project by Skjold Stall, where they will build a neighborhood with used batteries from Nissan Leaf. So there are projects coming, but unfortunately these projects like in Norway are not profitable for the moment. So it's more research projects. So the future in Norway for batteries, well, there is this new grid tariff that is proposed by NVE, which is the company deciding a bit what we should pay in our electricity bills. And basically they wanted to make people pay less for the total energy they consume, but more for the power peaks they were having. And that was really good for battery packs. But the first the first proposition they made was too complicated, and then they could, like, it was turned down. And now the new proposition coming is actually to have a more expensive fixed cost, which means that trying to do peak shaving has no purpose anymore almost. So it's reducing the initiative for residential market and commercial markets to use batteries to have the flattest consumption as possible by regulating the peaks, because you will not save money, because they don't want to make you pay more for your peaks. They just want to make you have a fixed cost. And I think that's not really the right way to go. That will make that any energy economy, like buying a heat pump or installing solar panels, it will be a worse business to do that a bit, and also batteries will be also a bit pointless if peak shaving doesn't make you save any money. So what we need and what we are working on is to have cheaper, more environmentally friendly energy storage. So in Greenstat Energy, we are really willing to use secondary used batteries in our projects, but we see also the need for new regulations that are promoting and facilitating the use of these technologies of batteries, because it's coming in the market and we need to have a demand on one side. I think I have maybe 1 or 2 minutes for questions, if there are any.
Yes, thank you, Charlie, for your talk. Charlie has to leave earlier today, so if there are questions to Charlie Berthaud, please ask them now in the question and answer field. If there are none questions, I would otherwise say we continue. I think there are no questions. I mean, I can introduce the next company. It's BTG Sol Energy. They are delivering lighting solutions for street lights. And I have to say here at that point, there is a tiny change in program since Rune, I hear now myself, since Rune Strandberg is presenting the presentation of BTG. He is actually a project engineer and has an engineering background. Welcome, and looking forward to your exciting presentation.
Thank you very much. Good morning, everybody. My name is Rune Strandberg, and I'm representing BTG today. So I will talk about our core business, which is solar lighting and other innovative and economical solar powered solutions. In this picture, you can see our main product, Illume 2.0, which is placed on a county road in Hardangerfjorden. So a little bit about BTG Sol Energy. Our core business is to develop, produce, and deliver solar lighting solutions for the Nordic markets. We're going from standard solar products to self-developed solution designed for Nordic conditions. When we say Nordic conditions, we mean long, dark, and cold winters. We're also aiming for nationwide sales and export, as well as an increasing degree of in-house production. So we have many exciting projects in the pipeline. A little bit about traditional outdoor lighting, as you all are familiar with, I guess. These need to lay cables to the areas that would need illumination, and airborne cables are very often thought of as eye pollution. It's not very nice to look at, as you can see from this picture. On the other hand, if you need to bury the cables in the ground, this is very expensive and also very time consuming. In addition to this, the costs of the power supply and fees are also very considerable. So all of these aspects won't be necessary with our Illume solutions. So this is an illustration of the cost for traditional lighting for a 2.8 kilometers walkway in Vestby municipality in Norway. So this was done by their councillor, and it's dated from 2018, so it's a relatively fresh example. Here you can see the cost for example, excavation, the laying of cables, the transformer, and the setup cost for the transformer. The total of this is about 7.5 M NOK, and this is not including the lighting itself. This will amount to about 2.7 million Norwegian kroner, meaning there are millions to save by choosing our solar powered product. Of course, you also have existing solar lighting solutions like this you can see on the picture here. These are not made for Nordic conditions. As you can see, you have so-called all-in-one solutions where you have the solar panels on the top and the pole beneath. These products work just fine in the southern areas of the world, like in Africa or in, for example, Spain, where you have a lot of sun, but not in the Nordic climate. The reasons being snow and freezing temperatures during winter, as long as long periods with limited sun. So the dimensioning of the product is the biggest issue. So what makes our solutions unique? The battery pack, of course, has a large capacity and is robust in cold weather. So our solar panels are of the type and angle which leads them to maximize the energy production during winter time. The panels are mounted vertically, as I will show you later on the picture. With a low winter sun, you get a perfect angle to the solar panels, optimizing energy production. You also have an intelligent design made to provide light when you need and to minimize the energy waste. So all in all, Illuma is made for Nordic conditions. Here you have the illustrations of our main products. You have Illuma 1.0, Illuma 1.5, and Illuma 2.0, as well as Illuma Flexi. So on the left side, you have Illuma 1.0 and Illuma 1.5. The difference between 1.0 and 1.5 is that you have 2 panels for the first one and 4 panels for 1.5. So you can see the Illuma 2.0 is an updated version of the first generation. So the difference here is that you have the batteries in the foundation or at the bottom of the pole, while on Illuma 1.0 and 1.5 you have the batteries behind the solar panels on top. So it's easier to maintain, and if you have to change the batteries, it's easier for doing that in the Illuma 2.0 product. You also have the pole is different in the 2.0. It's coned, so it starts with 20 by 20 at the bottom and ends up being 15 by 15. So that's also an addition. Illuma Flexi is our product designed for bus sheds. We use the pole and the solar panels from Illuma 2.0 and lay the cables from the pole and into the bus shed, where the LED lamp is placed and illuminates the shed from the inside. So I will now show you some application areas for Illuma. This one is from a place near a lake in Byglandsfjord. You have a marina outside of Kristiansand. Here the people they are doing some tourism. So they are taking tourists on a journey with these ships, and they wanted to illuminate the dock. So they used Illuma 2.0. Let's see, this one is outside a nursing home in Kristiansand as well. And this one maybe some of you have seen before, because this is placed at the UiA. So it's the Illuma 1.0 model, many places around the university area, including this outdoor fitness park. Let's see. This one is from our local place in Birkeland. We also have made deliveries to Sweden with our partners, Amparo Solutions. This picture is taken from, this is the first picture I showed you. And this one is taken from Mikragar Hotel in Kløfta. Here they got Illuma 2.0 and painted in a specific color to fit with the environment and with the color of the hotel. And this is our Illumiflexi and the belonging LED lamp on the right side. We also have a new product called Illumidret. This is which can be used for example, golf courses or other sports areas. We are also, as we speak, developing a new IoT system, Internet over Things. So this is a web-based control system, which will make the programming of our products a lot easier. You can do this from a laptop, mobile phone, or do it at home instead of today's solutions, which is with a remote control, and you have to be physically near the poles to program it. This is also much more energy efficient, so this will be a great addition for us. So last but not least, we are participating in this project because we find it really interesting, looking at the opportunity to use second-hand car batteries in our solar streetlights. As we are an innovative company, we would like to make this happen. So the questions we're asking ourselves are, can second-use car batteries be used in our solutions? Is it possible to develop an economical value chain for this? So these are the questions we need to answer. But just a specification, we are not at all battery experts, as many of you guys are. But we are open to collaborate and are excited to continue working with this project. So yeah, that was all I had, I think. Thank you very much for your time.
Thank you, Rune, for your exciting presentation. And I'm pretty sure that we find at least some answers or have some exciting discussions later on in the panel discussion. We're coming now to the last presentation of the second session. It will be presented by Ida Salomonsen Turrud. Unfortunately, she can't participate because her child is sick, but she sent me a video presentation, so she pre-recorded her presentation, and I'm very excited to see what she has to tell about batteries in electric boats.
Bernard, we don't get the sound from, or at least I'm not hearing the sound from this. Should we take the break now, a short break now, and then we can come back to Ida's presentation when we checked out the sound works, if she was just before the break. Should we do that?
Yes, we can do that. Sorry.
Yeah, no, so we'll take a 5-minute break now and then come back with this presentation then. So yeah. Super.
Yes, thanks.
Hi everyone. We're going to try going for the to play the video again now from Ida's presentation from Greenwave. So so Bernard will start that up now, and we'll see how it goes. Okay.
Hi everyone. I'm Ida Salomonsen Turrud, the CEO and co-founder of Greenwaves. I would like to start with a video presentation of our company.
Greenwaves, a technology company based in southern Norway, creates a more environmentally friendly experience at sea. We thrive to be an innovative and forward-thinking company, developing the electric boat technology for the future. It's all about being close to nature. Greenwaves focuses on sustainable and stable operations rooted in green technology. Our business model consists of 3 main components: converting existing boats, developing and selling new boats, and our core activity, which is developing and selling our own full electric propulsion systems. We started with our Greenwave 601 but have taken it a step further with the development of our new GreenWaves 630X. Norway's first serial-produced electric boat in aluminium, designed to handle the rough northern conditions. This is a 21-foot open boat with a specially developed hull, with main focus on developing the most energy-efficient hull possible. The result is a range of up to 100 nautical miles on one charge. It's important to deliver on the three criteria: speed, range, and price. We believe the best combination to deliver on all three is to limit the maximum speed to about 15 knots. The hull is made of recycled aluminium. Our two main reasons for choosing aluminium are that you can recycle the material repeatedly without losing strength or quality. It is also less labor-intensive to produce, enabling competitive production in Norway to create more green workplaces. We have now started developing our own optimized electric drivetrain with the GreenWaves 630X as test base. The propulsion system will be universal and therefore adaptable for a variety of different types of boats, both new and existing models. The GreenWaves system will come with an option of hydrogen fuel cell as a range extender, which we strongly believe is the future. Over the last years, we have seen a development in the boat industry where the size of engines increases every year. At the same time, more restrictive speed limits are frequently introduced. GreenWaves believes we need to stop and consider what boating is really about. We need to rethink how the boat industry affects the choices of boat buyers and how we can make it more sustainable. We believe the future needs green solutions and want buyers to have the possibility to choose an environmentally friendly solution, where the focus is to be close to nature, with a silent experience for both passengers and marine life, without all of the emissions. There is literally an ocean of opportunities out there. We just have to seize them.
We do see both challenges and drivers in the second-use battery sector. And in the end, for us, it's all about making electric boats more attractive for our customers. So we in GreenWaves have decided on only using lithium iron phosphate batteries in our boats. This is mainly due to safety and reducing risk. Because in the leisure boat market, we are currently lacking a specific legislation for electric boats. That doesn't mean that we don't have regulations to follow, but we have to take more precautions. So due to the type of lithium battery we have chosen, we won't be able to use the batteries from electric cars. But we see a huge value in using them for charging and energy storage for both private and public use, especially off-grid. So the three main challenges as we see them are price, safety, and weight. The price has to be significantly lower than the price of new batteries, which again means that the process around, for example, restacking the old batteries need to be more automated. And there's the safety aspect. We need companies that have a high quality control and the needed competence, such as batteriretur. And there's the weight. The older batteries have a higher weight than the batteries we see in the market today, which can be challenging. And then we have the drivers. In the bigger picture, it's of course all about the environment. But in order to get the customer on board, the price has to be right. So a potential significantly lower price than the new batteries would definitely be a trigger for the customer. And then there's the sustainable aspect of the product. The used batteries are a great resource that's already been produced and have a lot more to give. So that's definitely a huge driver in using the batteries repeatedly. We also see opportunities in using our boat batteries in a more sustainable, circular way all year round. If the customers aren't owning the batteries in his or her boat, it will decrease the price of the boats and also reduce one of the big hurdles around battery expected lifetime and so on. This again would make it more attractive with electric boats and also accelerate the green shift at sea. Thank you so much for all your attention.
Okay, that's great. I think Greenwaves is a really exciting company that are doing something quite different, where the opportunity is not is it for reuse is slightly different than other sectors, but interesting nonetheless. So I think Bernard's now ready to set up the next session and the next speaker. So I'll hand it back over to you.
Thank you, Stephen. I hope you can hear me again.
Yes, we can.
Great. So starting with the next session, which is about the keynote speakers as well as the panel discussion. And Ida in her previous talk mentioned already some of the big challenges when it comes to second use of batteries. And one is the price and safety. And actually the University of Agder is working on such issues with the concept of automated disassembly of electric vehicle batteries, which will hopefully ensure that the prices for batteries go down due to automation, as well as some potential built-in characterization sequences will allow to sort the batteries according to their state of health, which will in turn ensure the safety of the batteries. I would like now to introduce Martin Schuh. He is an associate professor at the University of Agder and has several years of experience with automatic control. He was working for ABB Industrial Robots and a lot more. So I'm really glad that he has time to give us this nice talk about automated disassembly at the University of Agder. Martin, the stage is yours.
Yes, thank you, Bernard, and good morning, everyone. So I'm going to, let's see. Yes, I'm going to repeat a bit what has been said, but in order to reach zero emission by 2050, then electrification is going to be a fundamental element, and green battery chain is going to play a vital role in this. And now the battery tsunami, or this high volume of end of first life used battery, is reaching Norway first, and then the rest of Europe a bit later. And we have to take care of this, possibilities that we have here. So we know that research and education in mechatronics, in AI, and in automation is necessary to establish battery recycling and reuse business in the south of Norway, especially because it's a region with a high labor cost. And this is the aim of the newly created top research center mechatronics at the UEA. And we have this application area, which is called battery recycling. And we want them to develop the technology to help in recycling and reuse these batteries. So we started our work in 2018, participating in the project which is called lithium-ion battery recycling. And now we are under the third year of this project. This project is owned by Hydro, and the main goal is to develop and commercialize a new lead recycling process that shall be suitable for the large future volumes and have a much higher material recovery rate than today's state of the art. So here you see the partners, And UEA is responsible for the work package 1 in this project, which I will detail a bit later. So this project, we know that it has already been successful because a new company has been created based on these results. And this is a Hydrovolt company, which will be building this new factory in Fredrikstad to recycle the batteries of electrical vehicles. So the work package 1 in this project is to disassemble batteries, but also automatically discharge and characterize the batteries. So we start from an electric car and get the pack out of the car. And this has to be disassembled into the modules, and each module includes several cells. And this process has to be suitable for large volume that are coming. And it has to be also able to deal with a lot of varieties of batteries. So, because one step which is common in repair and reuse and recycling is actually the dismantling of these batteries. So this is a crucial step in this process. And the challenges are that the batteries are coming in a large variety of models. Each car has its own design, and each maybe different design depending on which year it has been produced. And it comes also in different conditions. It can be dirty or disformed. And we have to recognize different components that can be more or less challenging. And it has to be fast and safe. It is a topic that is gaining a lot of popularities this last year. For example, beginning of 2020, so this year, in Germany, they started a new project with 13 million euro for automate this process of battery dismantling. We also have Northvolt, which is working on the topic to produce new batteries, but at the same time recycling the batteries with automated dismantling and crushing. And then we have a lot of activities in England also with the Faraday Institute, which also was quite early in this topic and has already published several articles here. And there are much more work that might not be aware of, but it is getting a lot of popularity. So what we are doing at UEA, so our approach consists of first making some 3D scanning of all the components of some specific battery pack like e-Golf and Nissan Leaf. And that will be used later for the training of the cognitive algorithm. And then we create disassembly plans for specific battery types. And the next step is to connect all the different components together in a robotic operating system. So we have a state-of-the-art 3D vision system that will be connected with a robotic arm with a table fixture to hold the battery or the pack, and some tools that will cut the connections and grasp and place and remove the parts. And we are building at UEA different cells, robotic cells, to implement and test these operations. So now we have a lot of robots available, and we will have maybe 3 or 4 different cells that will do different operations in this dismantling process. And next, we implement and test different cognitive algorithms for detecting the objects in 2D, but also segmenting the objects and estimating the location of each recognized parts, and then deciding automatically the disassembly process or the sequences by using decision-making algorithm. And finally, to plan the path and the operation, where to cut, where to grasp, or how to remove the parts. So we have some preliminary results. I will show you a small video here. So we want to implement a process that doesn't have a predefined path or assembly. The first thing is we take picture of the battery pack. At least three different sections. And analyzing these 3D images, we can detect where are the different parts that we want to remove. Modules and box. And then we move the robot to the precise location of each piece that has to be disassembled. So in doing this process, we have a flexible process that is able to deal with any initial position of the pack or any position of the components inside the pack, if there are some missing components or not, and if the components are overlapping, and to decide which order to remove the components. And in the next part of this project, we will implement the tools to actually cut the components and grasp and remove the parts. Yes, that was all for this presentation. Thank you for your attention.
Thank you, Martin, for your presentation. Very interesting which progress you already did. And I would like to welcome now our last speaker for today, Dag Albertsen from Battery. He's actually the plant manager of Battery, and I also just did my homework and I checked his CV, and I actually found out that he has already more than 40 years of experience in the field of batteries, because he's also the owner of a battery supplier called Vastec. So I'm really excited to hear what he or what his opinions are on the requirements for second use. Dag Albertsen, are you there?
Can you hear me now?
Yes, you can hear you, yes.
Oh, yes, nice, thank you. Okay, do you have the presentation?
Yes, I loaded the presentation.
Yeah.
If you want, you can request control, or I can switch for you if you want.
Yes, you can just switch to the next one.
Yes.
And to start, as you say, I'm in fact all my life been a battery man, so I'm in many of this battery business, kind of battery business, but what we are going to talk about now is of course this lithium-ion batteries and the new project about that. But first, some very short about Battery. Battery is more than one company. What I'm the managing of is Battery high energy, but we also have this Rebat for these small portable batteries, household batteries, and also there are a lot of lithium-ion, or at least, but this is only the small batteries. And we have collecting for more than 25 years this lead batteries, of course. That was the start for Battery. And we have started last year a new company called Battery Operation Norway, And the Battery Operation Norway is a company that are going to do a lot of work around this collection. For example, something about second life for batteries. Can you go to the
Yes.
one? Thank you. The company have this department in Sandefjord called Batteriretur High Energy. And this is about lithium-ion batteries from cars, from cars. We started, as you see, 7-8 years ago with this. It started with some 100 batteries, in fact, from one producer that they asked us to we have some problems with some batteries, what can we do them? And we started this project related to that, and started this dismantling and all the other things that we have been doing later on. The main focus is on electrical and hybrid car batteries. And we have Batteriretur have some agreement with almost all the producers and the importers, at least in Europe, and some from Japan. As we know, there will be a lot of Chinese cars now, so we will see what happens with them. But we have some agreement with them regarding to collect all the batteries that are taken out of the cars for some reasons, or at the end of life cars also. But in the late, let's say this year, we see that there are some increasing with this marine and industrial batteries. There are some truck importers that have lithium-ion in trucks, but mostly there are some increasing of these marine batteries. And for us, a marine battery is almost the same work or kind of work as electrical and hybrid car batteries. But marine batteries is always coming in module, not in they are not bigger than one module, but one module can be, for example, 24 cells or even more cells in one module. What we are doing, we are collecting, we are testing and dismantling all these batteries from the Norwegian market. They are popping up all over Norway, and let's say it's not a very big quantity at the moment, but at least one each day there are a truck, not a big truck, but a truck loaded with batteries coming to us that we are going to work with. We have this evaluation, we have packaging, and we have transport. We use external ADR transport for most of the batteries, but we have also a lot of batteries that are some kind of critical that we have to pick up by ourselves. And all this year we have been working with this. We have a lot of projects. Some are funded by the different kind of from places, but we have a lot of projects together with these operations. Okay, we can take the next one.
Yes.
I think we go directly here to one of these projects that we have been working with for some, I think it's about 3 years now. It's an R&D second life setup. The main office for Batteriretur is in Fredrikstad, in the harbor part there. And there we have built up a solar system that are going to work together with the solar panels on the top of one of the big buildings there. It has been in work almost 2.5 years from the first part we put in, and it has been work now half a year since we put in the third part, because we are in that project using battery modules. We always use modules, but of course we have done something also with the cells, but we use modules, and the modules is from 3 different producers, car producers, and also 3 different chemical solutions and type of cells. And that's a bit interesting. That was one of the meaning with this project, was to show that it is possible to have different kind of cells from different producers working together. But it's important to say that they are not working together in the same module or in the same. There are 3 separate systems with each BMS, especially made for this and that chemical solutions and things like that. It's a totally, in this small container at the moment is 360 kilowatt hours working very well. It's charged by the solar panels, and it's the power is out to drifting this headquarter in Fredrikstad. And we see it works very well, and we have this, you see there are some computers there, and we can see it also in Sandefjord, and in fact you can see it everywhere you want to see it and control this system. It's almost like Tesla control the battery in the car everywhere in the world. We can do the same here. I can open my telephone and look at this and see how it is. I can look at each cells. I can look at the temperature and whatever we want to see there. Okay, take the next one. It's I understand that today is one of the interesting topic is about the second use of batteries, what we can do with that. And some earlier on already have been talking about this, but what we see is that there will be a huge increasing in at least as alternative energy also said in the market for these used batteries. In fact, we have already know a lot bigger asked for these batteries than we are able to support to the market. We have some agreements. We have this with alternative energy. We have some few other companies, and we have also a lot of projects where we are going to put in different kinds of batteries from different producers for the future, where we built up, as I just showed you, this battery storage. What we do in Sandefjord when we have received a complete battery is always that we take it apart, we take out the modules, and the modules that not are going to be reused are going to be recycled. And as you just mentioned, this new factory in Fredrikstad that are going to recycle these batteries need to have the modules discharged. What we do, we take out the modules, we discharge all the modules down to almost zero state of charge. It's let's say the cell level can be something like 1.5 volt or something. Then it's no energy left because they are going to be shredded in that system, and as you know, there can't be any rest capacity if you are going to shred the battery. Then you will have a lot of fire and smoke, and that's not a good idea to have. So we can go to the next one. There are some challenges about second use. The legislation is not clear on who carries the producer responsibility, because the producer of, let's say, Volkswagen battery, if you are going to use some of their battery modules, they of course don't want to have the responsibility for that module in the next life, in the second use life. It's the same for all the producers. So there need to be some agreement about that the new producer that use modules or cells in a new application need to take the responsibility for that new product, also for the cells and the modules. It's a very important thing. And as you know, at the moment, some producers say they don't want us to use their batteries to any other project. They just want it to go directly to recycling. And one of the reasons is this, that they don't want to have any responsibility for this afterwards. And it's also like this, as you know, they are going to be built, or there are in these days almost half ready, a big factory in Sweden, Northvolt. And of course, for example, Northvolt say that their goal for the future is that quite soon, let's say 30, 40, 50% of the batteries they are going to produce are going to come from used batteries. They need, and because of that, they would like to have these used batteries in for recycling and use this raw material as soon as possible. So we see that some of these big factories, they don't want any batteries to be used for second life because they need a raw material quite quick. That could be a challenge. So, but in the future, in the Norwegian system, you know, when you have a EV and put it to the end of life to a car collector, biloppsamler, then it's not the car producer's product anymore. They don't own it and they don't have any real control of it. So of course the car collector can in fact give it or sell it or do what they want with it. That of course also is a problem because they do a lot with these batteries at the moment that not are secured enough. But then I think whatever the producers say, there can be a second life use for these batteries because they don't have the control of this anymore. So if the market are so that there are some need for this for second life, I think there will be possibility to use this for second life. Okay, we can go to the next one. Yeah. Some details in Norway, at least. The reuser company, we have heard some of them today, or other companies that want to use this product, these modules or cells. They need to have a written contract with Battery Retur. We have a standard contract that we use for that. They also need to set aside some for the future cost, because if you take the new product responsibility for that, you also will be the one that have to pay for the delivery when it's going to be going back for recycling later on. Because in Norway at the moment there are a real cost for recycling. We hope that let's say some years from now there will be a positive value on this, but at the moment there are quite high cost for put this in the recycler. Even in Fredrikstad there will be a cost for that. So there are no positive last value for this. During the cost is quite high, but we hope that will be changed in the future. We also think that at least if Battery Retur are going to deliver some modules or cell to a customer that are going to use this for reuse, the customer need to have, the company need to have some skills and some professional use for this, because we can't just, we never deliver some battery modules to what we call Petter Smart that are going to use this on private purpose on one boat or one cabin or something, because if something happened then we think that could be a catastrophe both for Battery Retur and for the producer of this, the original producer. There must be some, as for example, alternative energy told you, there must be some safety involved in this BMS system, and it must be produced and have some, for example, the balancing, temperature controls and limit values and things like that. That has to be in not outside the limit that was originally meant to be used for this battery. If you take a Volkswagen or a hybrid battery, Mitsubishi or something, You can't use it for higher load. You can't charge it lower down, or you can't do things that it's not meant for. You need to have some thoughts about that. There are some practical things. You need to remove all product marking and things like that. If you go to the next one.
Yes.
I think we have some short times here. Of course, if we have someone that want to use this for reuse or for some project, we need to take contact with the producer, and they have to say, okay, we can use these batteries for this and that purpose. And we then recommend the customer or the project for the producer. And then we have a lot of job with this, because when we open the battery and take out the modules, we already start some measuring of the modules. Because if you have a Mitsubishi Miev, for example, that have been in the market for 12 years now, it's no idea to use the modules for second life if they are too big difference between the cells in the modules. Because as you know, the lowest cell voltage is the weakest cell in that module. And if that capacity is too low, it's no idea to use it. So maybe in the future, there will be, as we see now, let's say 30–40% of the batteries from end-of-life vehicles will be good enough for second use. There will be a big market for batteries from end-of-life cars, but I think there will be never be like this, that almost more than 50% is useful for a second life. Maybe just 20–30%. But of course, even in Norway, when we are collecting, let's say 50,000 batteries a year in not so many years from now, 20% of that is a lot of batteries for second life use. So, what we do as an option today, if the customer wants, we can test, we can even look at the state of health. We can say what capacity is in each module. We can, if a customer wants to have 10 or 20 or whatever modules, we can balance the cells and the modules so they are totally equal before we deliver to use in some systems. That is what we are already doing a lot of today. So that's a purpose that we can have some agreement about. But as I said, conflict between the producers that want to have these used batteries back as soon as possible for the raw materials, and the market that want to have batteries for second life use. Of course, a lot of this depends also on the cost and of the price for this. And to be able to do this with the lowest possible cost, this dismantling of batteries and this discharging and balancing and everything, we are in these days, and also together with the University in Agder, but also here, concrete plans for building a prototype automatic dismantling, discharging systems for this. I think we will always need a lot of people, at least for the dismantling of the complete battery, but we are looking to whatever we can have automatically with whatever robots and other helps together with the people working with this. Okay, I think that was short about some of the doing.
Thanks a lot, Dag, for your very, very interesting talk. I think now it's time for the panel discussion, and I already got a lot of interesting questions, and I ask all the presenters to stay online, and I will direct the questions which are dedicated to them directly to them, and I hope you can, or I'm pretty sure that you can provide an appropriate answer to the questions. We just have some rules for the panel discussion. So we will now answer the questions which popped up during all the presentations. And if there are new questions arising, please use or please continue to use this questions and answer tool. Or you also will have now the opportunity to use the hand symbol, then you will grant access to physically talk to the speakers. Great. I will switch now. I will stop sharing the presentation now and switch to the questions. And I got already one which is dedicated to the first talk, which was my talk, which is about. I got asked if second use, or the question was that second use will delay recycling and hindering potential access to relevant raw material. How this may affect the second use business case. It's a very good question, and actually I discussed this quite a lot. I have a bit of a different approach to that message. Of course, second use hinders the raw material to go to recycling, but as of now, the recycling processes are also not optimized, meaning that, for example, in some non-optimized processes, I just heard that you can lose, for example, 60% of the cobalt in batteries. Meaning that as long as, for example, there are no regulations how batteries are labeled, you cannot appropriately sort batteries and feed them to optimal recycling processes. Also the quantities, but it's personal opinion, also the quantities of the different kind of batteries are too low to develop, as of now, appropriate recycling processes. And one thing on top, you mentioned that batteries will delay, or like the recycling will delay and will hinder raw material. This is true, but also if you do second use, you also inherit that first use storage is built for that purpose. For example, if there's a need for an off-grid system on a cabin, whatever, if there wouldn't be a second use system available, you would even need more raw material to build a first use storage to compensate for the alternative in terms of second use storage. So that's my answer to that question. Then the next speaker, I just follow now the program that we keep track. So the next question was directed to Repack, and Repack got an answer, which standards are used to get the type approval of your second use battery storage system, both in terms of safety and performance. Is something missing in the regulatory or standard frame? So I don't know if Radu or Jürgen, you can answer that question.
Yeah, I can try to take a quick stab at it, although I have a feeling that other people might be better equipped to answer. So from our understanding right now, there is a gap in the regulatory requirements for this. There are no standards at this point in time. The only one we are aware of is a UL 9074, which is a joint US-Canadian standard for repurposing of batteries. And then there are just the regular CE certifications and safety standards that everybody needs to follow with all electronic systems. But if anybody can complement that answer, it would be fantastic.
Yes, this was actually also a question which was directed to Alternative Energie. Maybe they have an answer on that as well. Otherwise, I have other questions for them.
Yes, we have worked quite a lot on this issue to do this conformity on the battery package. So, but there are missing standards here. There will come some more next year. But currently, we are working after NEK 485, which is for batteries for with normal batteries, and we are also working with the NEK 400. So we are using these two standards at the moment when we are making our CE marking on the battery package. But when the new standard for lithium will when that will come next year, then we will of course use that.
Great. I have also some other questions directed to you. They are just coming and popping up. So one question was, where do you get the batteries from? I think this was already answered by Battery, I guess.
Yeah, so normally we get the modules, we get it in modules from Battery, so they have then already done a check on the batteries. We also doing visual inspection here. We also doing measuring of modules before disassembling, and also the cells before we putting it into the system.
Mm-hmm. That actually answers already the second question I would like to ask you, which safety tests you do. There's another question, which is, do you also plan to buy cells from electric two-wheelers? And if so, what are the terms of purchase?
To buy it from?
Electric two-wheelers. I assume it's like e-bikes and e-motorcycles.
No, I think we will concentrate on the cells from cars. It's about the capacity in the cells, because it will be a huge amount of cells.
Very much work.
Yeah.
Great. Then we have some questions to Dag, actually, from Battery. So there is a very interesting question from Pertti. He asked regarding removing the original label from batteries, as you mentioned, for second use, how this complies with the perspective, for example, on battery passport concept, which is highly discussed on European level. And it's also needed, like the labeling is also need or would be needed for further optimal recycling processes.
In fact, I don't have any answers on that. That is clear, because as I said, also the regulations is not clear. So in fact, we really don't know how to do this and how it will be in the future. But we see now that at least the producers tell us that we should take away all labels, and that the new producer, for example, alternative energy, then have the responsibility for this product. But of course, I understand it's a problem with that, because then you don't have any information about the first producers of the cells or the modules. So, but you must also remember that not for alternative energy, but for other purpose. Sometimes we built the modules, we only use the cells. So it's depend on what do you think, because, for example, the cells in the maritime batteries that we also can use for second life, they are equal for almost all the producers. It's the same cell coming from a cell producer, and if you use only the cell, you don't even use the module that is from some module producer. So it's not so easy to say how this will be in the future.
There is also another question for you. I think I can combine some of the question, because one of the participants asked, how do you know which module can be used for a second life and which not? And another one asked, which are other criteria than the capacity to approve batteries for second use? For example, do you check the history? They ask to estimate the state of health, or what are the procedures you're doing?
Well, at the moment, the situation is a bit special, because you must remember that almost at least 80% of the batteries coming in through Battery today is from batteries that have some problems and have some guarantee cases. It's not end of life, because even in Norway, there are not many cars that have reached end of life. And we see that if it's, let's say, 400,000 cars, EV cars and hybrid cars in Norway now, about 2% of these batteries in these cars will get some problems before the guarantee period is out. So most of the batteries coming back now is that kind of batteries. And then it comes from an original dealer of the car and the car version. And then we get in our secure safety systems, we will get a diagnosis from that battery. At all batteries coming in, we have a complete diagnosis. We can see how when it was registered, how many kilometers it has been driving, and we can see a lot of other information. So we are sitting on all this when we are collect and select batteries and battery modules for second life at the moment. But in the future, that will not be so easily to have, because when you get it from a car collector, they don't have this information. That is how we do it today. We can, for example, say to alternative energy that this and that module is from a car battery that has only been driven 20,000 kilometers or something, and then we know that it's a new. That's together with what we can do is check the state of health. And of course, in Norway, some battery problems is related to that we have this salt on the water, on the roads, salt on the roads in the winter. We have a lot of rain and things like that. So a lot of batteries get problems and are shifted because of corrosion problems. And when we take out these modules, we can see, and if we see some proof about there have been some problems with the corrosion started, we don't use that modules, of course. So there are many things we are looking at before we say that this module is okay for second use.
Okay, and when we are always getting this age and kilometer from battery retour, and we are keeping track of this, in which battery packages we are using this, and we are testing each battery package after it's built, and then we have the capacity, and we are getting quite some data now for a long period. So this is a really important data to get for us, the kilometer and the age.
Yes, great. I have another question regarding your storage in Borghafen, Dag. One of the participants asked how you ensure the same voltage within the different packs. Different batteries have different SOCs and corresponding pack voltages.
Yes, but there are, as I said, there are 3 different systems, but they are only, so there are 3 different systems with 3 different EMS, and this on the DC side is working as 3 systems. It's only when they are going out to the AC system, they are connected together and giving the power out. So it's even if it's in the same container, it's like the systems working for each other.
Yes. Great. There's another question regarding this password of cells, modules, and packs. They asked, or one of the participants asks, if there is a documentation describing the specification, whatever of the battery, when you receive them, and also if it's considered to use batteries in second use applications from the logistics sector, for example, from forklifts.
I'm not quite sure what you.
So the question is, I hope I understand it right. So the question is, if you get second use cells from battery retour, if the reuser gets also some kind of documentation along with the batteries to know how to program the BMS, for example, and is it also possible, or is it also done that second use from forklift batteries are used in second use applications?
At the moment, we don't use forklift batteries because there are very, very few.
Yeah.
But regarding advice about BMS and volt, what we can do is giving some advice about limits for the voltage and whatever you need to know about cells. But if you as a customer are going to use it, it's your responsibility to build it up in the right way.
Yeah.
But most of the batteries we use for this now, we have some engineers here that are involved in this project together with the customer.
Yes.
It's both way, in fact.
A last question to you. How do you store the batteries when they come into your facility?
Well, the battery is coming as a complete battery, and we have some storage. I think at the moment maybe there are some 300-400 batteries there that are in storage waiting to be dismantled, and some batteries that are critical or unsafe. We have in fact 6 or 7 45 feet containers, what we call security containers, that we put in the unsecure batteries. Because you know some batteries are unsecure because they have some, for example, been in a cracked car or been badly handled some places. Something can happen when you take it out of the car. Or one of the criteria for calling a battery critical is if they have some leakage in cells of electrolyte, for example. Then we call it a critical module or a critical car battery, complete battery.
Great. I think I have asked most of the question. One final question I just missed when I went through all the questions. One is dedicated to BTG. Maybe Rune, you have an answer on that. So the question is, do you have any solutions for charging the batteries when the temperature is below 0 degrees, which is assumed to be critical for lithium-ion batteries?
Yeah, so currently we use AGM batteries, simply because, as the person who asked the question mentioned, lithium batteries won't charge at low temperatures. So the reason why we're here is because we would like to look into the possibilities of using second-hand EV batteries. So we have looked into this before, but when Stephen and Bernard and the crew contacted us, we got very interested again. So the short answer is, per today, we need to test this over a longer period to see if it is good enough to meet our needs, basically.
Maybe I can have a comment on that, because it's not a problem to charge lithium batteries in -10 degrees, not a problem, but you cannot fast charge them. So all our the battery packs we are selling used in cold conditions, and it have never been a problem, but you can not fast charge or fast discharge.
Yeah. Do you have some documentation on this? Maybe you can send me later.
What you don't need a documentation, I think, because the most of the electric cars in Norway do not have heating of the battery cells, and they are used in -10, -20 degrees. Not a problem.
Thank you.
I just see I missed another question. I got just informed. The question is to Batteriretur, and the question is, I guess it's hard to predict future prices of second life batteries, but how are the price figures for now? I'm okay to pay a fee per kilogram to Batteriretur. How much will pay at the end in euros per kilowatt, as an example? I expect that second life batteries is cheaper than new batteries, but what is the gap between first use and second use batteries? If Batteriretur can say some words about that.
In fact, we can't, because first of all, there will be some deals between the customer and Batteriretur, and someone have some diagram about the market prices earlier on, and I think it's depending on, for example, the battery modules state of health. Is it some modules that have 90% rest capacity, or is it 50% or things like that? We can price it different. I would say more that if someone needs to have some concrete answers about that, they can make a mail to me, to dag@batteriretur.no, so we can take it from there maybe.
Great, yeah. Thanks a lot. So I think I'm through with all the questions, and I really want to thank all the speakers and also the participants for this really nice talk. At least to me, it enlightened a lot of questions I had in mind when it comes to second use, and I hope you also have your takeaway message from this short workshop. Thank you again for the participation, and if you have any further questions or remarks, please send me a mail and I can lead it forward to the responding persons. As I mentioned already in the beginning, we will also share the presentations after the meeting. I think that was it for me. We are a bit over time, but I think the 5 academic minutes are okay. So hope to talk to you soon again.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Goodbye.
Thank you. Bye-bye.